What if the nucleus of 3I Atlas, this mysterious interstellar visitor, is 15 kilometers wide? That's a staggering size, potentially rewriting our understanding of how such objects form and travel through space. But here's where it gets controversial. Recent data suggests this could be true. Yet the numbers might also be hiding a cosmic trick. Let's unpack the clues and the debates they've sparked. New observations from the Zwicky Transient Facility ZTF camera. Shared in a preprint study, https://archive.org/pdf/2509.08792. Trace the path of 3I Atlas when it was 6.1 times farther from the Sun than Earth is. What makes this discovery remarkable isn't just the object's origin, it's the way it brightened over time. Starting in early June 2025, ZTF data shows a steady increase in brightness, hinting at mass loss from 3I Atlas. By July 21, 2025, the Hubble Space Telescope captured a glowing aura around the object at 3.8 AU from the Sun. https://iopscience.iop.org/article 10.3847.2041.828 PDF. But here's the twist. This glow wasn't uniform. It stretched 10 times longer toward the Sun than in other directions, as detailed here. Avi Loeb.medium.com/the sunward glow in the Hubble image of 3I Atlas is 10 times longer than it is wide. 3A5CFF257A94. This lopsided glow suggests the object is shedding ice fragments which vaporize under sunlight. A paper co-authored by Avi Loeb and Eric Ketto, https://archive.org PDF 2509-0771, argues this is unlike typical comets, where dust tails are swept backward by solar radiation. Instead, 3I Atlas's glow implies a different composition, or perhaps even an artificial origin. But let's rewind. Between May 15th and June 1st, 2025, ZTF data shows no growth in 3I Atlas's apparent size. This plateau in brightness, if the object was simply reflecting sunlight from a fixed surface, we'd expect steady brightness. Yet the lack of change during this period hints at something more. The authors of the study compare this phase to a model where the nucleus is 5.6 kilometers wide, based on Hubble's imaging. But here's the catch. This size estimate depends on the model. If the plateau reflects the bare nucleus before mass loss began, the true diameter could be 5 to 10 times larger. That math leads to a jaw-dropping conclusion: a 15-kilometer wide nucleus. For context, the previous interstellar object, 2I Borisov, was estimated at just 0.75 kilometers. See Table 2 here. www.annualreviews.org/docserver/fulltext astro 61 Anurev astro 071221054221.pdf expires 17584116 ID guest checksum DFBACB12C8343EFAA 14653A6. At 20 times larger, 3I Atlas would be 8,000 times more massive, assuming both have similar densities. And this is the part most people miss. If 3I Atlas is this massive, why haven't we seen thousands of similar objects before? The universe's interstellar rock budget seems insufficient to explain such a behemoth. Could 3I Atlas have taken a rare, direct path into our solar system? Avi Loeb explores this in a paper, https://article/10.3847.5172.ade06, and a follow-up co-authored with Om Trivedi, https://rxIv.org/pdf/2509.0630. One theory: its trajectory was engineered, aligning suspiciously with the ecliptic plane, as noted here. https://rxiv.org/pdf/2507. Is this a natural anomaly or a sign of advanced technology? The question alone is enough to fuel debate. Of course, the data isn't perfect. The ZTF plateau's early error bars mean this 15-kilometer estimate could be overblown. But help is on the way. On October 3, 2025, NASA's HiRISE camera aboard the Mars Reconnaissance Orbiter will image 3I Atlas from 29 million kilometers away. https://nasa.gov/mission/Mars Reconnaissance Orbiter. With a 30-kilometer per pixel resolution, HiRISE will pierce through the glowing haze and measure the nucleus's true brightness. This data will be 100 times more precise than Hubble's, offering a definitive answer. Science, at its best, is a detective story. As Sherlock Holmes famously said, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. The HiRISE images will be our magnifying glass, helping us separate fact from fiction. But here's a final thought to chew on. If 3I Atlas's size and trajectory defy natural explanations, does that make it a technologically artifact? Or are we simply missing a piece of the cosmic puzzle? Share your take, agree, disagree, or let us know what you think the data means. About the author, Avi Loeb, Harvard's former astronomy department chair and founder of the Black Hole Initiative, has spent decades unraveling the universe's mysteries. A best-selling author of Extraterrestrial and co-author of Life in the Cosmos, he's no stranger to pushing boundaries. His latest book, Interstellar, https://products/interstellar-Avi Loeb, dives into the science and speculation behind objects like 3I Atlas. Whether you're a skeptic or a dreamer, his work challenges us to rethink what's possible in the cosmos.